This is 8.3, testing the difference between means for dependent samples. So 8.1 and 8.2, we had independent samples, meaning they could not be paired or matched. Now we're going to be dealing with samples that are dependent. We're going to be using the t-test as opposed to the z before. So the t-test for the difference between means. If the samples are dependent, first we want to find the difference, or d, between each data pair. So we're going to start with x1 minus x2. Now the test stat for the mean before was the difference between the two means. The test statistic for the mean is going to be d bar, which is the sum of all of those d's divided by n. So the sum of the difference between each pair divided by the number of total pairs. So to conduct the test, the samples 1 must be random, 2 must be dependent, and that's the difference from section 1 and 2 when we were using the z-test, and the populations must still be normal. So the equations that we're going to need, which will be given to you on the test, is first the test stat, which is d bar, the sum of the d's divided by the number of numbers, or number of pairs. The standardized test stat, which we're going to use the t, which would be d bar minus mu sub d over the standard deviation over the square root of n. And the standard deviation can be written as the sum of d minus d bar squared over n minus 1. Okay, we could also rewrite this just to help us a little bit more as the sum of d squared minus over n all over n minus 1. So let's try a problem here. It says the shoe manufacturer claims that athletes can increase their vertical jump heights using the manufacturer's new strength shoes. The vertical jump heights of 8 randomly selected athletes, so my n is 8, which means my degree of freedom is going to be 7, are measured. After the athletes have used the strength shoes for 8 months, their vertical jump heights are measured again. The vertical jump heights for each athlete are shown in the table. At a level of significance of 0.10, is there enough evidence to support the manufacturer's claim? So start out by writing your h sub o and your h sub a. So we're looking for the mu between the d's. So the claim is that the athletes can increase their vertical jumps. So if my d is supposed to be the starting point, which in this case is the height before, minus the ending point, which would be the height after, we would expect to get negative numbers for each of those. So we would expect our mu to be smaller than 0. That's our claim. So the opposite for h sub o would be true. Looking at this, I see that this is going to be a left-tailed test because that's the direction my h sub a is pointing. So looking at my t chart at 0.1 and a degree of freedom of 7, I find it to be negative 1.415. Now I need to find all of my information so that I can plug it into my t equation to test, seeing if it's in the rejection region or not. So they give me the heights for before and the heights for after. I will need d and d squared. So they say the first one was 24 and after the shoes was 26. 24 minus 26 is -2. -2 squared is 4. They tell me the second one before was 22, after was 25. 22 minus 25 is -3, squared is 9. The next one was 25 and 25, no change. 28 and 29. 28 minus 29 is -1, squared is 1. 35 and 33, which would be 2. 2 squared is 4. 32 and 34. -2 squared is 4. 30 and 35. -5, which gives me 25. And the last pair was 27 and 30, which is -3. Squared is 9. So in my equation, one of the things I needed was the sum of all of the d's. So -2 plus -3 plus 0 plus -1 plus 2 plus -2 plus -5 plus -3 gives me -14. Also the sum of d squared, which would be 56. So now we have all of our information that we can plug in. Start by finding d bar, which is the sum of the d's, which we found to be -14, divided by the total number of pairs, or n, which was 8. Then we need our standard deviation, which we said is the square root of the sum of d squared, which was 56, minus the sum of d squared over n, and the whole thing over n minus 1, which was 7. So I was just plugging it into this equation here. So now plug it into your t. Your t is d bar minus mu sub d, which we were comparing it in both of these cases to 0, over the standard deviation over the square root of n. So looking at that, it is in my rejection region, so I would reject h sub o. Since I'm rejecting h sub o, the claim is the only thing left, so I am supporting the claim that their shoes improve your vertical jump height. Let's try one more. On page 454, it says the state legislator wants to determine whether her performance rating from 0 to 100 has changed from last year to this year. The following table shows the legislator's performance ratings from the same 16 randomly selected voters from last year and this year. So these are paired because it's the same 16, which means my degree of freedom is going to be 15. At a level of significance of 0.01, is there enough evidence to conclude that the performance rating has changed? Assume everything is normal. So start out by writing your h sub o and your h sub a. It says the claim is that there will be a difference, which means that when you subtract them, you do not get 0. So my h sub o would be the opposite. That means I'm looking at something that's two-tailed. So I'm going to look at my t-test at a degree of freedom of 15 at 0.01. Two-tailed is going to give me -2.947 and 2.947. And now I can go into all of the parts. So there's 16 of these, so it is a little bit longer. I'm not going to list the before and after. They are on page 454 and 455. Let's just list out the D and the D squared. First one is 60 and 56. 60 minus 56 is 4, squared is 16. 54 and 48 gives me 6, squared is 36. 78 minus 70, 8 and 64. 84 minus 60, 24 and 576. 91 minus 85, 6 and 36. 25 minus 40, negative 15, squared is 225. 50 minus 40, 10 and 100. 65 minus 55, 10, squared is 100. 68 minus 80, negative 12 and 144. 81 and 75, 6, squared is 36. 75 and 78, 45 and 50, 62 and 50, 79 and 85, 58 minus 53, and 63 minus 60. So again, if we were to sum the D, I would get 53. Sum the difference squared gives me 1,581. Start by finding your D bar, which is the sum of the differences divided by the total number of pairs, 53 over 16. Then find your standard deviation, which would be the sum of the D squareds minus sum of the D squared over 16, all over 16 minus 1. And lastly, plug into your T equation, D bar minus mu sub D, which we were looking at 0, over the standard deviation over the square root of n. So looking at this, it is not in the rejection region, so I would say fail to reject H sub O. And since I'm not rejecting H sub O, it's not the only thing left. So I would say not enough evidence at 1% to support the claim. So we will start this assignment together on